Hey there, Russ here. Welcome back to the shop. Today I want to go over the wiring and the components of making my portable power unit here. I actually am now calling it a portable power pack. Thank you, George. It was his idea and he's right. This is more like a power pack than a power station. So PPP it is. If you're interested in building this, you're going to want to know some of the basic components of what I did and why and what you should and shouldn't do. And I'll kind of go over that so we can make it so that if you decide you want to make your own, you should be able to. And from what you'll learn here, not only can you do this using Ryobi batteries, if you wanted to do this with DeWalt batteries or some other brand, there's no reason why you can't. The only thing you have to change is your connector between the battery and your power pack unit. So I used the one that George made me. That's these little caps here. And I was able to attach my terminals on. And that's in another video. So I don't want to get off on a tangent. I do that all the time. But I do want to mention one thing here real quick. And that is this. If you look here, OTB Thinker. And that's at CPAMOMY. CPAMommy.com. 1M. Don't make fun of that address. It's a long story why I have that. But anyway, if you want to contact me, you want to give me some diagrams or send me a picture or something, you'll be able to send it to here and I'll get it. So, but don't tell anybody this. I'm not going to write it down on my YouTube channel because then all of a sudden you get all that junk mail. This is secret. It's only between you and me. Shh. Don't tell anybody else. I won't either. So, anyway, we got that out of the way. That, yeah, my Les Nessman moment. We'll talk about this in a minute. So basically, let's go over the wiring of this unit. Now, when I built this, there was a couple things I did, and a couple things I would do different that I already see if I was to start over, but I'm not going to change at this point. First and foremost, let's talk about the elephant in the room. This is just a simple couple pieces of Velcro strap and a piece of PVC pipe. My finger is all swelled up. I put this on there to help keep it splint so I don't use it to bend it because that's when it hurts. And now that I've immobilized it, it does much better. Yeah, I could have gone to the hospital and got one, but I couldn't see spending $150 giving it to the hospital for what I did here in 10 minutes with a little hot glue and a couple other things around the shop. It works pretty well. It does keep my finger immobilized, and since I put this on here yesterday, my finger feels a lot better, and hopefully now it'll start healing. What caused it? Quite honestly, it was my own mistake. I have, on this unit here, I have wires running everywhere, and every single wire I have put together with terminal ends of some kind that crimp. Now, if you ever make one of these units, I really truly advise you to use soldering connectors instead of crimping connectors. But basically, I use these darn crimpers in a one-day period, and I probably did 150 different crimpings of making all this different wire stuff up, just a huge amount. And quite honestly, I think I overtaxed this finger when clamping it back down. That's when it started hurting. So sometimes I forget that I'm old and don't do that. And it wasn't until 2 days later I realized what was really going on. By then I really was swelled up. So, live and learn. If you're going to do this, just be prepared for other problems. So, I overdid it. And like I said, if I had to do over, and I really advise you to use solder. I was too lazy to get the soldering station out and start doing it with using solder. But that's what I should have done. Another story, your connections will stay cleaner, longer, and less likely to fail when you use soldering. Now, I tend to do it this way with crimping because I got most of my experience in doing DC work early on. It was all done because I was an automobile mechanic. And when I started doing that stuff, I learned pretty quickly I had a knack for understanding DC voltage and how it worked and relays and all that stuff on a car. And so as a result, my 12 volt 48 volt, doesn't matter. DC type current, I actually know a lot about it, understand everything there is to know about it, really. And so I do tend, and because I was in the automotive, I tend to take and crimp connectors. That's the way it was done when you did work in a car. You just used crimp. So you had to make darn sure that it worked and that it stayed connected, didn't fail. So I got pretty good at doing connectors, because there was a few times when they come back a week later and I didn't have one of the connectors crimped down very well. So I learned pretty fast how to do it properly. So I'm not afraid to use crimping type connectors, but you really got to know what you're doing if you're going to crimp them, because there's a lot of points of failure every time you do a crimp. That's a potential point of failure. So soldering does work better, and I do recommend do as I say, not as I do. Anyway, with that in mind, and with my bad finger now, hopefully this will go away and I won't have to make fun of Les Nessman anymore. But until it does, you just have to put up with this as my pointing finger. So let's talk about my wiring here. First off, let's look at a couple of the major components that I have on here. I've actually got these batteries hooked up, 4 batteries right now, hooked up to my connector with the wires running. Everything's going to a aluminum block. There's 2 of them on this side, which are for the 18 volt stuff, every 18 volts coming into the system. Over here, I have 2 more terminal blocks that I have, and this is all 12 volt. I've marked this clearly as 12 volts. And this is everything that has come out of the step-down converter, and it's going to my plug-ins, my cigar lighter plug-in and my USB port and those types of things. And I'll go into all that after I show you the diagram. So I have a 12-volt side, and that's what these 2 blocks here, they're just aluminum pieces, 3/16" aluminum. I drilled 5 holes in it and tapped it for 1032 screws. Used a washer and a lock washer so that I could actually screw these terminals down and anchor them all into one terminal block. So, and that works pretty well. I have an 18 volt side over here where I have a positive and negative terminal block here, and the same thing, so that all the wires from each of these batteries go to either the positive or the negative, one from each batteries, the wires. And that's kind of how the wiring goes in this. So when the main component you have to do this is a step-down converter that will go from 18 volts to 12. I believe this one was spec'd out at 40 volts maximum down to 5.5 on both sides. So you can start with up to 40 volts and drop down to as low as 5.5. And as long as you're higher on the input than you're on the output, the electricity flows through. And that's the way it works. So that is a critical part. I paid less than $20 for this one. It's 12 amps, which means that you have about the same amount of current, pretty close to the same amount of current that you get off of a regular household current. Those run either 10 or 15 amp circuits generally. So, and this is 12. You can run almost any appliance that you can run on a wall, that you can plug into a wall. You should be able to plug into here, most of them, unless it's a dedicated outlet, like for refrigerators and stuff. That draws a lot more than 12 amps, so you don't want to use that, plug that in here. But normal small household things can now be plugged into this unit and run it off of these 4 batteries. So let's get into the diagram itself so you get an idea of what all the components are that make this up and what you need in the way of wiring in order to bring this to a reality. This is my wiring diagram. Let me zoom in on it a little bit. Whoop, right there. Okay, so I think this will work. So I have my battery pack over here, 4 batteries. Each one has a positive and a negative. These are my 2 terminal blocks on the 18 volt side. So all of these have a wire going to each of these blocks, negative here, positives here. And then I also hooked up a voltmeter that has a positive wire that goes to this block and a negative wire goes to this block. And this measures my accumulative voltage on my batteries. Now I have this on the 18 volt side because that's what you have to monitor. The thing will always put out 12 volts because these 18 volt batteries start at 20.5 volts. And as you use the voltage up, when they get down to about 15.1 volts, they shut down. They put out 0 volts. They just shut down. So this is the monitoring point. It's like the fuel gauge. As these things drop off in voltage, I know I'm getting closer and closer to the shutoff point. Over here, if I had the meter, it would read 12 volts all the time. It's always putting out 12 volts. So that's why I put the meter on this side, so I can monitor what's going on. I also, on this 18-volt side, I put a cigar socket right here. And the reason for that socket is so that I can add additional batteries to this system. I take a plug-in like this with two terminals, a positive and a negative, that associates to the plug-in on a cigarette lighter. And then I can take a regular cap, similar to the ones I use there, that has the positive and negative. When I pop this down on top of the battery, and then I just hook this up to each side of the battery, and I plug that in, and I now added a battery to my power pack. So instead of having 4 batteries, I actually am planning on making a little pigtail with 2 of these, with this hooked up to it, so I can add 2 additional batteries on the fly by plugging it in here. Then I'll have 6 batteries on my power pack. And the reason for that is that these batteries, you do want them all to be pretty close to the same comparable battery. And I am using 5 amp batteries, Ryobi 5-volt batteries. And what I'm doing is that when you plug them all in, it's like water in several tanks, that you have a hose going between all of them. When you start draining one, they all drain down at the same level. That's what happens with DC current on battery storage. So if I plug these 2 into here, instead of having 5 times 4, having 20 amp hours of battery storage, I would have 2 more, which would give me 30 amp hours of battery power that runs my 12-volt pieces, whatever I'm running. I can then run, and so my battery source will last longer. If I put a 12-volt fan and plug it in on the 12-volt side, and it's drawing 12 amps an hour, then with 4 batteries, I'm draining 3 amp hours out of each battery in an hour. That means that thing's going to run for 4 hours before it runs out of juice out of these, because it'll drain them all down at the same time and equally. If I put 6 on there and now have 30 amp hours, and I'm running a 12-volt amp fan, now it's going to run that much longer. It'll run 50% longer by adding these 2 batteries in. They'll all drain down at the same speed. So try to make sure your batteries are reasonably the same charging capacity when you start. In other words, charge them till they're fully charged if you can, so that they all pretty well start the same. Now, these batteries do have a light gauge on them. See if I can do this. There, see? So if I push the button, it shows you 4 lights. If all 4 are lit up, it's theoretically fully charged. So I always check them before I pop it in here, make sure they're all reasonably fully charged. And that way you get your best utilization of your storage power when you're using the unit. So anyway, back to the unit. You have your step-down inverter here. Everything on this side is 18 volts. I can add batteries through this cigarette light socket. I can monitor it through the fuel gauge here. And I can hook up all 4 of my batteries, initial ones, they're hooked up directly with the individual connectors. Right here. So all 4 of these batteries, 2 on the back side and 2 here, are just sitting here hooked up. And they're hooked up. They're hooked up in series. So that's why I'm getting the 20.4 volts on the whole overall system right now. If I unplug one of them, it'll still read 20.4. As I start draining them, they'll drain equally, and I'll be able to see the voltage drop. So once everything comes in here, everything goes to a single aluminum block, 1 positive, 1 negative. Negative side, positive side. And then coming off of each one of these terminals is 1 wire that goes into the step-down converter. 1 on the positive, 1 on the negative, and that's on the input side of your step-down converter. On the output side, I have a wire that goes from here to another terminal block, and here, the negative to a terminal block. So I have a 12-volt negative terminal block, positive terminal block, and a negative terminal block. And all of these components run a wire, 1 positive, 1 negative, to each of them to run these off of 12 volts. These are all 12-volt designed outlets. So right here, I will put a fuse. You want to put a fuse in here because this is your main input voltage that feeds the voltage to everything on your output. So if you fuse it right here, that will, if you overload anything, that'll blow this fuse, protect the step-down converter, and it'll blow all the power from going to everything else. So this is the only place you actually have to fuse. You can put fuses on them individually, but this one alone is all you really have to have. Also, for safety, I'm going to input a power switch right in here between the terminal block and the step-down inverter on the 18-volt side, and that switch will cut off all power to the step-down inverter and everything else beyond. To take the battery voltage away here, I have to pull the batteries out individually, but that's just the way it works. So you don't need to fuse anything here or do anything like that. There is going to be no problem with drawing these. So if you want to put some kind of fuse on there or something individually, you can do that. That would be up to you. You don't need to. So that's how this system works. Now, as far as the 4 components here that I have on the output, I have a cigar socket, so I can plug in any standard 12-volt into it and run it off of a 12-volt socket. I have a USB port socket where I can plug 2 USB items into this. I have a set of jumper cables that I've hooked up, so that little alligator clips, so I can hook them up to give 12-volt power to anything. And I can also use these clamps that if I put all 4 of my batteries in here, and if I have a battery that won't start on my car, but it can't be totally dead, but if you have a battery that, let's say you can just hear it going, just won't quite start, or if all you get is a click, 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 there's a good chance that if you take this and alligator clip to your positive and negative respectively, you should have enough power to jumpstart that car. So you can actually use this to jumpstart a car or hook it up to any 12-volt item. And as long as you don't draw more than 12 amps out of it, whatever you hook up to, you can use those cables to hook up to it. So I have clamp hookups, USB, cigarette lighter, and this is my inverter. You have one positive, one negative that goes into here. And this inverts all the DC power to 110 voltage. I have plugged in a light. I plugged in my orbital sander into this outlet here. When I had 4 batteries in, and I plugged it in and ran it for about 10 minutes and didn't see any appreciable change in the voltage on it as a result. It seemed to run. I suspect that it would run that sander for an hour, if I took a guess at least, and potentially longer. Depending on how many amps that thing actually draws, and if I have 20 amp hours to begin with, you can do the math. And I did once. I can't remember how many hours it would run. But basically, as long as you're running nothing more than what you can run with plugging into a regular normal plug-in outlet, you should be able to run it on this with 4 batteries. If you need that extra kick to make it last longer, plug in all 6. You can do that too. So this is the wiring diagram right here. You have 18 volts over here, your converter, and 12 volts over here. I've gone over the list of all these items. If you want to know, I just kind of found them on eBay. I found some generic cigarette lighters. I used the same cigarette lighter here that I used over here. I just have the 18 volts wire going to it instead. It doesn't care how many volts are in this outlet. You just want to make sure what you plug in there is compatible to that 18 volts. Don't plug a 12 volt in there. You could have a problem. So, other than that, so this is more designed to be able to add battery capacity to the unit on the fly. So, anyway, that's the electrical in a nutshell. I'm very happy with the way it came out. Like I said, there's just a huge amount of wiring here. Now it's time for me to kind of clean it up, mark all my items here as to what they are. What's my 18 volt plug-in, my 12 volt. Excuse me. And there was a lot to go over here, I have to tell you. I hope I didn't go too fast for you on how these wires work. I hope I also explained to you about how to use soldered connections instead of crimping connections. I'm not afraid to do it because I've done it for so long that, to me, I can do both, and I know it's going to be right when I'm done. But unless you're really good at it, the odds of having one not work is very good. And boy, what a nightmare it is to find which one that is if you're having problems. Troubleshooting electrical wire is the challenge. So, me, no big deal. Especially since I designed it, I can work this out. So, that's everything right there. If you have any questions about how this works, how the wiring diagram is set up, or where you can find any particular component you can't seem to find your own, let me know. Oh, if I said it before, but these terminals here, this is nothing more than an aluminum bar. And it has to be thick enough that I can cut threads into it, so when I screw a screw in, it'll bite into some threads to hold it. So I didn't buy terminal blocks. Those things are expensive when you think about it. I just made my own, so it didn't cost me anything. So right now, I have less than $40 in this whole unit, and it actually works, with the exception of my batteries, which I don't really consider that because those batteries I use every day as it is. This just means that I can use this for the additional $40. I have a nice little power pack unit that I can carry somewhere and get some pretty good power for quite a while if I want. So, wiring diagram, in a nutshell. If you have any questions about it, you need me to explain it a little bit better or different or slower, let me know. I'll see what I can do. But this should be enough information, even if you have to go back over it 2 or 3 times on your own. You should be able to get all the information you need to be able to build your own if you want. This should help you get the electrical part done. So, don't be afraid. One more look. This is the electric diagram of everything. So you can freeze this and look at it here. You can kind of see all the wiring. The positive on the 18 volt is blue wire. The negative is black over here. Everything is red, that's positive wire, and everything that's black is the negative side. That's all there is to 12 volt, to DC voltage. It's all one positive, one negative, and that's it. So it's pretty easy to figure out how it all works. What helps me is to think in my mind that when it comes to DC power, it's like running water. It runs from uphill to downhill. It runs from positive to negative. And it's running downhill all the way. It doesn't go back. So, keep that in mind. Hopefully this did it. If you have any questions, you can email me. Shh, don't tell anybody that email address, but you can email me if you want. Or just leave a comment below. Don't be afraid to hit that like button if you learned something here today, or if you like this video. It helps me know that I'm doing the right thing. Most importantly, please come back again because I'm nowhere near done. And where do you see my next project? It's really cool. Let me say it involves my panel saw system and a circular saw. We'll talk about it soon. Thanks, and we'll see you again. Oh, and my OSB wall, I'm still working on that. I'll give you an update on that in the next day or so you can get an idea where I'm at. So, any questions, just leave them in the comments. Thanks. You guys have a good day. We'll talk to you again soon.